we had a hard time trying to record last time you weren't with us.
I'm so sorry.
No, it's fine. We're just trying to remember how we were supposed to do it because you always do it. So we're like, how do we record this?
I handicapped you. I'm so sorry.
Yeah, it's okay. Okay, let me complete it. Okay. So the first question, TV
Question 3.
simulation app. Yeah, question 3.
Ah,
So we're supposed to have these two data files, right?
mhm.
I'm gonna open them up in Excel.
Okay. I'm trying to get SPSS to work for me.
Okay. The flat data files, right? Chapter 12, data A and data B, right?
Mm-hmm.
It's so weird they don't give the option to download them in an Excel format.
Yeah, I did think that was weird.
I have to go to the data files and download them myself. It's fine. But,
Okay.
okay, I already downloaded both of them. Okay. So do you guys want me to read this paragraph over
Yeah,
here?
if you want.
Okay. So it says let me turn this on. Suppose we have a set of paired data and let d x after minus x before. The null hypothesis is equals the null hypothesis is 0. The alternative hypothesis is something different than 0. And the population standard deviation is sigma. Deviation sigma is not known. Jordan collects a sample size of 9 and computes d 2.2 and the standard deviation of d 3.3. What is the value of the test statistic? So in order to find the test statistic, we just find t, right?
Mm-hmm.
Okay. So we
As
just like
I understand it.
so we just use the formula
Mm-hmm.
Yeah,
that I think I
zero
have.
standard deviation over the square root of the population.
Yeah. So t equals d minus 0 over standard deviation square root of population. So we
We got 2.
I'm working on it. So 2.2, 3.3, and
So Keith, you said you got 2?
Yeah,
Okay, for some reason I keep getting like a decimal answer, which doesn't make any sense. So
are you getting 0.2 too?
yeah.
Me too.
2 minus 0 divided by 3.3 divided by the square root of 9.
Yeah, so 2.2 divided by 3.3 divided by the square root of 9, right?
Uh-huh.
And I'm getting 0.22. That's my t. Oh, my test statistic. What was your answer again, Keith? Did you say 2?
Yeah, just straight 2. You can see that's not backwards or anything.
That's crazy. Let me see again.
Oh, I see. Okay, let me do this again here.
0.6. Okay. Let me do it again. I don't know what I'm gonna do. Maybe it's just how I.
Okay.
Maybe the order.
Okay, now I have 2.
What do you do different? The order of operation?
Yeah.
Or,
So instead of doing, I just, instead of like putting it in my calculator square root of 9, I just put, I just put 3
yeah,
instead.
I got 2 as well.
Okay.
Yeah. So that's the value of test statistic.
So for the probability of obtaining a test statistic greater than Jordan's test statistic, I can't talk, is 0.0403. Use this probability to determine the p-value for Jordan's hypothesis test.
So we just plug in. Wait. This test.
My guess was to plug it into the
The applet?
probability.
Like in the area part?
Yeah, because what they give us is the t-score, isn't it, technically? 0.04.
Because I thought the p-value was the area.
Yeah, so if we plug in 0.0403 into the applet,
The area comes up at the top.
the p-value will give us the probability.
Okay, so
I think, I don't know.
0.
Yeah, because isn't p-value the area?
Yeah, exactly. That's what I'm.
Okay.
Because so when I plug it in, it's giving me a t-score of 3.472.
No, we're supposed to plug it in for the t-score first, and then the area is the p-score, or the
p-value.
yeah. And so we're looking for
Oh yeah, because the test statistic is 0.043, right?
yeah,
So that's why you plug in the bottom.
yeah,
403. And then we're looking to something greater, right?
yep,
So we just shed it to the right.
yeah. And I got 0.484.
I got
That's what I got.
0.48. Wait. Where's 0? I'm getting 0.485.
Eh?
I don't know why.
Camilla, what the?
Because so I plugged in the t-score. I plugged in 0.0403, but it's only showing 3 decimal places, so it's showing 0.040. That makes sense.
And then your area should be 0.4844.
What is it? That again?
0.4844. Did you do the?
Did you do what? Sorry.
The degrees of freedom. Did you do those?
No. How many degrees of freedom we have?
8.
Oh, maybe that's why. Oh, now I got it. 0.484. Yeah.
Okay.
Thanks, man.
Yeah, not a problem.
I'll tell you what, this class is giving me 0 points of freedom. Oh, so sick of this. No. Okay. So, anyone want to do question 5? That was the lamest joke ever, but
5.
okay.
It says use the data to answer the next 6 questions. Perform paired samples, t-test, and SPSS. Be sure that the test does group 1 minus group null hypothesis and alternative hypothesis. What is the test statistic? So
So be sure that the test does group 1 minus group 2. So is that data A, right?
I think. Yeah. No. Yeah, it's A.
Okay.
But it says it.
Are you guys using Excel or SPSS?
Yes.
I'm still trying to get my SPSS up. The thing.
I should use SPSS, guys, because sometimes Excel is giving me weird answers. Or at least I blame Excel.
Oh, okay. Be sure that the test does group 1 minus group 2. Okay.
Hypothesis 0. Yep. And
I got
Final.
0.407.
Not equal to 0, right? That's the type of test we're doing. Not equal. And then level of significance is so the level of significance is 0.10, so that will be a confidence level of 0.90, right?
Yeah. Remaining.
And he's asking for, and we're looking for the test statistic. And let me see how much I got. I got 0.407.
I have 0.382. What am I messing up here?
Just make sure the well, I don't know how to use SPSS, so Keith, you tell her. Because I'm using Excel.
Camilla, what did you get again?
0.407.
Is that what you got, Keith?
What mean did you get?
Are you asking me or asking Haley?
Haley.
Oh, I'm getting 0.342.
For your mean?
Oh, not for my mean. That's my answer. I'm just looking over it again. Oh, I see what I did. Okay. Hang on, let me. And
Do you find it?
0.9. Okay, I got it. Okay. Yep. 407, right?
Yeah.
0.407.
Okay, got it. Sorry.
So the p-value, next question, I got for p 0.689.
Okay, I got that.
Yep.
What is the correct decision
It's
based
so
on?
cool that, oh, sorry.
Oh, go ahead.
No, I was just going to say it's pretty cool that we don't have to do everything by hand, that we just plug it in.
Yeah, it's a lot better.
Yeah. Sorry, you can go ahead.
Oh, you're fine. What is the correct decision based on this evidence?
Fail to reject.
Yes.
What is the level of significance that we're using? Oh, 0.10.
Yeah.
Yeah, and we got 0.689. Yeah, we failed to reject, right?
Yeah.
Okay. Okay. Question 8 says, suppose.
Oh, go ahead. Go ahead, come on.
Okay. Sorry. Suppose your alternative hypothesis is instead. Wait, how do you say that again? It's not
Greater
sigma.
than 0.
No, yeah, I know it's greater than 0, but I don't know how to say the letter in the Greek alphabet. That's mu.
Mu.
Yeah. So mu greater than 0. So what is the correct decision based on this evidence? Let me change that here.
I put
isn't it C?
I still get the same. I still get a greater p-value.
Yeah, so I put B.
What do you choose, Keith?
B, the second one.
Oh, insufficient.
Yeah.
Agreed.
Yeah.
I'll read the next one.
Go for it.
Use the data file to answer the next 8 questions. Perform a paired sample t-test. This data comes from, anyway, the null hypothesis equal to 0. The alternative is not equal to 0. Alpha is 0.01. Which is greater, N or EF? Would be N. Because it's
What you said, Keith?
9, so it'd be N. Which is greater? Degrees of freedom, you subtract 1 from your
Oh, yeah.
Yeah.
True.
N will always
Sorry.
be greater.
Oh, because it's 0.9,
No, you're good.
right?
I
Once you-
don't really understand the difference between the group sample and degrees of freedom, because it's like basically the same thing, right?
Yeah, it's just a different way of. It's a
It's
different
just
way.
a difference of 1.
Yeah. Like, I mean, I don't understand why we just use 1 minus the sample size. Well, the sample size minus 1. That's degrees of freedom. But
Yeah.
whatever. So, okay, so next question, it says, what is the p-value? Okay, let me do that. Let us do that. So, the
0.427. Does that sound right to you at
I
all,
got-
Keith?
No,
I'm still working on it.
0012.
Wait. I'm working on it.
You said 0.012.
0.0012.
But once you round to 3 decimals, just 0.001, right?
Correct.
Oh, okay.
What do you get, Keith?
0.0012 is what I got.
Yeah, same.
Okay.
So 0.001.
Check.
Yes. So
Okay.
11, reject the null, right?
Correct.
Yeah.
So
And
12, try another alternative hypothesis. This time you use this particular thing. You keep the same level of significance. Did the p-value increase or decrease?
So
Decrease.
that's greater.
So it increased, right?
Decreased.
Yeah,
Oh, I read.
yeah, it decreased. Decreased to 0.0006.
Because mu is greater than 0, right?
Yeah.
Okay, got it.
So that's 12. 13, what decision do you make? Reject the null or fail to reject the null? We still reject it.
Correct.
Yeah. I feel like Keith is our our grader. He's like, I've already submitted this, so I'll just.
Yeah, like we do things and like, Keith, what do you get?
Okay. Based on your response from the previous question, what conclusion do you make? We have sufficient, insufficient. Oh, let's see.
It's a C.
Yeah, it's C.
Okay, because that's what I would have put is sufficient.
15 says, as we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value?
The very bottom one,
Greater than? Let me see.
when u is greater than 0.
Yep, greater than 0.
Yeah, that's
I just
Okay.
did it.
Okay. We're almost done. Okay,
It's
determine
not, yeah.
determine the 95% confidence interval for the mean difference between the two groups. Input your answers below. So what is the point estimate for this 95 confidence interval?
So that means in the confidence level, we write 95, right?
Say that again?
So in the so that means the confidence level, it's 95%, right?
Yes.
The same. So the point estimate. 1 minute group question. Do we have to do that by hand or do we look at Excel?
So I did mine in SPSS, and technically all it is after you do a paired sample, it's the mean.
Sorry, I don't know that one.
What is it?
It's the mean technically after you do the
The-
paired sample.
So is it
I
the
got
mean
11.
of the differences?
Yeah. So make sure.
So 11.955.
Yep. Because that's the point estimate. So the formula, the point estimate is what you add or subtract the confidence level and the standard deviation to,
Mm-hmm.
which is technically the mean.
So wait,
Oh.
so is the answer 11.955 or do we use that to find?
Yeah,
the
that's
point
it.
estimate?
That's the answer.
Oh, really?
Yeah.
That makes
Oh,
sense.
see. Okay. Point estimate.
Margin of error for 90.
Wait,
Oh, what?
just so why is the mean the point estimate again, Keith? Can you repeat that one more time? Sorry, I blanked out right now.
The answer?
Yeah, why is it the mean of the difference?
Or why is it that?
Yeah.
So the point, so if you go to the formula, so to get the interval, you add or subtract the mean to the z-score or t-score of the confidence interval.
Or of the margin of error, right?
Yeah, and so the mean is technically the point estimate.
Oh yeah, I just read it. Sample mean difference point estimate. Yeah. Okay.
Yeah.
Cool. Thanks. So the margin of error for this 95%, that will be
Hit the letter. Oh, sorry. Okay. Margin of error.
so okay. So in order to get the margin of error, it's t times the standard deviation over the sample size, right?
Yes.
That's how you guys did it.
Right?
I did mine differently, but I got mine wrong, so I'm trying to look it back up.
Okay, let me see if I can get it. So it's t for do you guys? So what is t for you guys? For t I got 3.737.
Okay, that's well, I used my crappy calculator, but I'm a decimal point away from that, so
Okay.
37 for t.
Did we use the standard deviation of the difference, right? So that will be times 15. Do you guys get the same standard deviation 15?
yeah. I have 15.
Over 22. So how my formula is looking, my equation, it's 3.737 times 15 over the square root of 22.
Yeah, that's what I'm doing.
Okay. So I got 11.950.
What did you get?
11.950.
So yeah, that's what I got, but that don't make no sense.
I know.
Why would it be the same as the point?
It's not the same, but it's pretty close.
11.950?
Yeah, because the mean is 11.955. So it's pretty close,
well, yeah.
but it's not the same. So it's actually, so if we were to round, well, I don't know if we have to round it up, but it will be 11.951. Are we doing it wrong?
Keith, what was your original answer that you got wrong?
5.5.
Hmm.
It's worth a shot, I guess.
Yeah, because I don't think we're doing anything wrong. I mean, we're following the formula. We have t standard deviation over 22. Well, the square root of 22.
That's just so weird they're that close together.
Yeah. It's a kind of big margin of error, right?
Yeah.
Oh well. Oh well.
Input
So you
lower.
got 11.50, you said?
Yeah, 11.950 because it doesn't ask us to round up, so I'm not rounding up.
Yeah.
But if we were to round up, it will be 11.951.
So yeah, it doesn't say it. Normally, doesn't it normally say to round up?
Yeah, it doesn't say anything, so I'm just gonna leave it like that. Hopefully I'll get
As
it.
0, you mean?
What is that?
You're gonna leave it 11.950.
Yeah.
Okay.
Maybe you should try to round it up to see who get it right.
Right. Doesn't it
So
always say to do that though?
I think so, yeah. Maybe you should actually do it.
You should try it, Haley. Okay, I'll do 1 and you do 0.
Okay. So for the lower bound, I have 5.303.
Yep. So I got
Say it again.
5.303.
Oh, okay. I thought you said something totally different. I was like, well, okay.
And the upper bound, I got 18.607.
yep.
I concur.
What is it?
I said I concur.
Okay. I think we're done. Or do we need to check something else, or do we just? Are we done
Oh,
with
we
this?
got 15 wrong, guys.
You got
What?
which one?
You got 15
Yeah.
questions wrong?
No, no. No, I got question 15 wrong. Did you guys get it wrong?
Wait, I haven't submitted. So is it actually 11.951 in 17?
Oh, no, I'm talking about 15. Did you guys put D, mu is greater than 0?
Yeah.
Yeah.
That's wrong.
I think it might be not enough information because I picked A the first time. We just did D. So it'd either be B or not.
But
Not enough information.
B doesn't make sense because I'm changing in Excel right now. So look, if I do greater than type of test, I get 0.0006. If I do not equal to, I get 0.001, which is bigger. And then less than, I get 0.999, which is way bigger.
So not enough information.
Probably is that, yeah.
Hey, what did you guys put for 4? It was 0.484, right?
For question 4,
Yeah.
yeah, that's what I did. Do you get it right? Do you get it wrong?
It's wrong.
What?
0.484 is wrong. And 17, by the way, says 11.951 is wrong.
It's wrong too?
Yeah.
You got three questions wrong.
Yeah.
Which ones did you get wrong?
4.
4, 15, and 17.
Okay, so maybe we did it greater than.
I'm sitting here trying to figure out why 4 is wrong.
4 was confusing from the start because we were not sure how to do it. Probability of obtaining a test statistic greater than.
So I got 4 wrong the first time around because I did a two-tailed test. So I thought doing more than would give us the correct answer, but I'm not sure now.
On 4?
Yeah.
Hmm.
So I've already tried the two-tail, and we just did the more than, and so then
Like
should
what's
be because less than doesn't make any sense.
What are we talking about? Question 4, right?
Yeah.
use the probability to determine? So for the probability, would you use the area to determine the p-value, right?
The p-value is the area as well, so I don't understand why. Because usually we use the z-score or the t-score, which is a test statistic to get the probability. But this time is given as probability to find the p-value.
Yeah.
So that's why I'm confused.
The fuck? Sorry.
0.4.0
I'm like scanning over the book to be like, what the heck?
0.0403. So the probability greater than. Okay. Do you think maybe it's worded incorrectly?
Maybe, but what else would it? I mean,
Because it could ask use this probability to determine the t-score for Jordan hypothesis test. Because that's what we usually do. We find the t-score and then we find the p-value. But I don't know why it's giving us a p-value to find a p-value. That doesn't make sense.
well, who cares if I correct the next two? We'll only have one wrong, and I'm okay with that.
Yeah.
I give up on the question.
We should type the t-score. I want to type it. Or we can screenshot it and send it to the teacher.
What the heck else would it be? That doesn't make any sense.
No, crap.
Did you get it wrong too?
No, by 17. I got it wrong again.
Why?
Because I just typed in 11.95.
Oh,
Wait, guys, what do you? I got wrong. Question 5 too.
I didn't get 5 wrong.
Which wasn't it? Oh wait, it was 0.407, right?
Yeah.
Yeah, I forgot to type in the point.
Good
That's-
job.
Hey, and for question 4, they're not asking for a t-score either because I tried to type the t-score, so I typed in 1999 and it wasn't. So yeah, just letting you know.
Jeez.
But I'm going to ask the teacher. I'm gonna send her that question to see what she says about it, and then maybe we could. I'll text you guys whatever she replies. All right.
Mila, what'd you put for 15 then?
15. Oh yeah, not enough information. Depends on the problem.
Okay.
Yeah, I got that one right.
Okay.
Okay.
Well, I guess we'll get together tomorrow and do one.
All right.
And we'll battle through it so Keith can get on to whatever else he needs to do.
So tomorrow 8:30.
Yes, if that works for
Sounds
Keith.
good.
Okay, perfect. That works for me too.
Okay.
Okay. See you guys
Okay.
tomorrow.
All right,
Thanks,
see ya.
guys.
Good night. Bye.